All right, hello everyone, this is Mr. Crozier. I'm going to go over a couple things that we covered in class today that are very important. First off, we have a graph of a function here that is x squared minus 3. It's a simple parabola shifted down 3 spots. And there's 3 theorems that we want to know: intermediate value theorem, mean value theorem, extreme value theorem. The intermediate value theorem says that from -1 to 3, if I look at that, at this point to this point here, it covers from -2 to 6, meaning if I were to draw this here and make a chart of inputs to outputs, sorry, those are the wrong values there. If I input -1, I output -2, and if I input 3, I output 6. This range from -2, every number there is covered with these inputs. This function is continuous, so every number I pick in here, if I pick -1, I could find an input. If I pick 5, I could find an input. If I pick 4.2, I could find an input. Every value between these is covered by these inputs. And that's just the intermediate value theorem. A lot of times what we do is we say, is there a 0 in there? And yeah, there is a 0 in there, so we go back and find the 0. All right, mean value theorem is about slope. Well, the slope from this point to this point, if I look at that slope right there, that slope is 2. What the mean value theorem says is that there is a point on there where the slope of the graph is equal to the slope of 2. Now we know this function has a slope of 2x because that's the derivative. So if I set 2x equal to 2 at this point 1, which is right here, at this point 1, they have matching slopes. That's mean value theorem. And probably the most important theorem of all is the extreme value theorem, which says that all extrema, maxes, global mins, all of those occur at the endpoints or when the derivatives equal to 0 or undefined. So we have to check endpoints, zeros, undefined. So the endpoints of this are -1 and 3. And then what I do is I take the derivative, set it equal to 0, and that comes out to be 0. So these are the points that I need to check. If I want a max or a min, I don't have to check 2 or 1. I just check endpoints and critical points. And then if I want to make a graph, I could put 0 here, and we'll see it slopes down, then slopes up at 0. So that's a minimum, but then we have a global max and a global min also. So the most important one by far is extreme value. The extrema are at the endpoints or when it's undefined. And the last problem we did today talks about the rate. The rate of water being pumped into a tank is here, V of t. So this pump, or this rate, gives the amount of water pumped in at gallons per minute. Well, if I want to find the total water pumped, well, that's saying with this velocity, I need to integrate it and go back up to position. So I integrate it from 0 to 4, and that gives me the total change in gallons. 52 thirds gallons of water are pumped into there from that time because I integrated a velocity function which goes to position. All right, and what about the last one, B? The max rate during that. Well, here's my equation, and I want to find the maximum rate of that. Well, what does that mean? That means extreme value theorem. That says if I want to find a max of a particular equation, well, I look at the endpoints, 0 and 4, and I look at any critical points. Where is the derivative equal to 0? Well, this derivative is equal to 0 at 1. So these are the points I need to check, 0, 1, and 4. Well, what do you notice about that? That's a minimum right there. If I were to come out here and do this minimum value of 1, I will see it goes down and down. Well, I'm not looking for a minimum this time. You gotta be real careful. A lot of times we just jump to this answer and think it's 1. We're looking for the max rate, and the max rate is going to occur at 4, not 1. 1's the minimum. So extreme value theorem, very important. The extrema are at the endpoints or where it's undefined. And in this case, we have a max here and a min here. The question asks for the max. And that's in gallons per minute because it's a rate problem here. All right, hope this helps. If you have any questions, please see me in class.